Amides are classified into three types of base under names: primary, secondary, and tertiary amide. The differences are classified based on the position of nitrogen atom linked to the carbon atom in a molecule chain. The position of nitrogen atom is not common for three different amides. A nitrogen atom links to a single carbon atom in case of primary amide. The nitrogen atom links with two carbon atoms in case of secondary amide, while in tertiary amide, the nitrogen links itself to three carbon atoms.
The simplest amides are derivatives of ammonia wherein one hydrogen atom has been replaced by an acyl group. Amides are usually regarded as derivatives of carboxylic acids in which the hydroxyl group has been replaced by an amine or ammonia. Amide can also refer to the conjugate base of an ammonia or of an organic amine. For discussion of these anionic amides, we need to see the alkali metal amides.
Physical properties of amides. Methanamide is a liquid at room temperature. Its melting point is 3 Celsius degrees. Ethanamide is a solid that forms colorless deliquescent crystals with a melting point of 82 Celsius degrees. Deliquescence means a substance that picks up water from the atmosphere and dissolves in it. These hydrogen bonds need a reasonable amount of energy to break, and so the melting point of the amides are quite high. Solubility in water. The small amides are soluble in water because they have the ability to join its hydrogen bonds to the water molecules. It needs energy to break hydrogen bonds, and then energy is released again when the new hydrogen bonds are set up to allow this to happen.
Alcohols. Alcohols fall into different classes depending on how the OH group is positioned on the chain of carbon atoms. The first one, that is the primary alcohols, is the OH group that is only attached to one alkyl group. Then there are secondary alcohols, where the carbon with the OH group is attached directly to two alkyl groups, which may be the same or differ, and then the tertiary alcohols, where the atom holding the OH group is attached directly to three alkyl groups, which may be any combination or different. Hydrogen bonding occurs between molecules where you have a hydrogen atom attached to one of the very electronegative elements, like fluorine, oxygen, or nitrogen. In the case of alcohols, there are hydrogen bonds set up between the slightly positive hydrogen atoms and ion pairs of oxygens in their molecules. The hydrogen atoms are slightly positive because the bonding electrons are pulled away from them towards the very electronegative oxygen atoms. In alkanes, the only intermolecular forces are the van der Waals dispersion forces that make hydrogen bonds much stronger than these, and therefore it takes more energy to separate alcohol molecules than it does to separate alkane molecules. That's the main reason that the boiling points are higher.
Properties of amines. The properties of primary and secondary amines are mainly altered by the hydrogen bonding. The reason for the elevated boiling points of the primary amines is that they can form hydrogen bonds with each other, as well as van der Waals dispersion forces and dipole-dipole interactions. The boiling point of secondary amine is a little bit lower than the primary amine, with identical number of carbon atoms. The lower boiling point is due to the lower dipole-dipole interactions and the dimethylene compared with the ethylamine. The boiling point of amines is usually lower than those of the alcohols. Gaseous amines acquire a distinguishing ammonia smell, whereas liquid amines have characteristic fishy smell. The majority of aliphatic amines exhibit some solubility in water because of their ability to form hydrogen bonds. Solubility decreases with the increase of the number of carbon atoms. Primary amines react with ketones such as acetone.